Hello everyone and welcome back. So in this module, we'll be talking about malware analysis. You might say, okay, why we do need malware analysis? We can understand the attack. We know now if we are in the defense side, we can just learn incident response and forensics, and that's enough. We don't need to go into the malware. But the truth is, malware analysis has really important information provides the incident. The first thing is that it discovers all the hidden IOCs, all the hidden indicators of compromise, which means some malware, if they do communicate with one domain actively, if this domain is a variable, but if not, they connect to other domains. So they have a list of 5-10 hidden domains that are not used until the first domain is basically inactive. That's the first thing. So when it's blocked, they connect to the second one. The attacker now knows that the first domain has been blocked inside the organization. Now he can prepare and give the malware another list of domains, just in case, and so on. Not only this, many samples we have seen, many malware has been used in the wild. They don't use only malicious domains to connect to attacker or suspicious domains. They go after legitimate websites like Twitter, like YouTube comments, Pastebin sometimes, and they save all their new domains. The attacker provide the malware with the new domains through these channels, through these legitimate channels. So if you block the domains today, the malware will be connecting to completely new domains the next day, because the attacker has still communicating with the malware through Twitter or through WordPress or whatever, and he's still providing new domains to the malware. So you need to understand exactly what is the malware is doing. In your logs, you might see malware.true, and you see that a suspicious domain, you block that domain, and you think that now you are safe. Then the malware connects to next day, every day he's connecting to a Twitter account, and from this Twitter account he's getting the CNCs he should connect to. Once malware.true is not working anymore, he will connect this Twitter account, he will get another new domain from the attacker, and then he will connect to this new domain. Next day he's connecting to legitimate.true, for example. So he's trying now to be hidden. You will see a new malicious domain coming up in your feed next day. So with malware analysis, you can discover all of these mechanisms that the malware is using, and the attacker is using as well to send new domains, and you'll discover all the other IOCs. You will discover this Twitter account. You will discover how to decrypt this new domains the attacker is sending, and have an automation to block them every day. As well as see what other machines or what other machines in your network that connects to this Twitter accounts. You can see all of them, and that's just one part from why malware analysis is useful. Another part is decrypting the CNC communication, understanding what is the data that the attacker stole, what type of data he stole, and what exactly he's searching for, and as well, you will understand the malware capabilities, what exactly what the functionality it gives to the attacker, how it does that, and how it spreads. All of this information you will understand through malware analysis, and all of that will help you to fully eradicate the attack. You can use the antivirus disinfection techniques. You can use the EDR disinfection techniques, but none of them will be able to fully eradicate all the malware all the time. They miss a lot of things that might make the malware return back again and again. And with malware analysis, you're able to understand how these things work. Another thing about malware analysis, that malware is not only the exe file or the assembly file that you get at the end. That might be, the malware might be a malicious document, might be a PowerShell command, might be a PowerShell that's running in your system and you don't know what this PowerShell is exactly doing. Is it from the administrators or is it from the attackers? And what exactly this PowerShell code is running. You might see it in some logs, you might see it in a scheduled task, and you need to investigate further. So malware analysis is a bit, it's more broad than just analyzing an exe file. It is analyzing any malicious tool or even activity running in the system through analyzing, through reading the code and reverse engineering the code. So how malware analysis is being done? Before we talk about the malware analysis process in details, there's one thing you should understand is what questions exactly I need to answer. If you are the malware analyst in your team, you need to answer specific questions related to this attack. If you have your goal in mind, you will be able to go to the answers to that question faster. You'll be able to basically customize your malware analysis process to answer these specific questions. Sometimes some organizations, they need to answer one question. What are the domains that the malware is connecting to? So you need to look for that inside the malware, then analyzing the whole code. Sometimes they give you a PowerShell script and tell you, is that a malware or not? Is that malicious or not? What exactly the functionality it gives to the attacker? Does it get Active Directory information? Does this split the privilege? Does it maintain persistence? Is it a malware or not? If that's the question, then you can answer it easier. If you need the brief information about what it does, then you can analyze it a bit further. If you need the full analysis, then you can go into a full malware analysis process. So you really need to understand what exactly the questions you want to answer. Some of these questions are, what is the capabilities of this malware and how much control it gives the attacker? This is a very common question. How does it communicate with the attacker? Through HTTP, HTTPS, what are the domains, what are the all the different CNCs are there? Does it update the CNC? Does it use domain generation algorithm? How does it maintain persistence? What are the indicators of compromise? What type of encryption is used in this malware? Can we decrypt the bcap? Can we extract the commands and the exfiltrated data? This is a very important part because that helps us understand the attacker motivation and as well as understand what data has been stolen and what's exactly the cost of this attack. Can this malware spread through network? Does it use a vulnerability in the system? Does it use the new Exchange vulnerability or a new Microsoft SMB vulnerability? How exactly it's spread through network if it does? So this is some of the answers, some of the questions to answer. If you're working in threat intelligence, you might have different questions to answer, like how complicated is this piece of malware? Does it share a code with a known family or a targeted attack? Does it share an encryption key or an algorithm with another known malware? Does it include a CNC that shared another attack, or even the IP? Even if you resolve that CNC and it gets an IP, this IP has been used in another CNC in another attack. So you have let's say malware.true is being used with this malware, but this malware.true, you resolve it as an IP and it becomes 100.100.100.100. That's it. Then you saw that this IP exactly has been used with another domain before called suspicious.cc, for example. Suspicious.cc has been used in another attack 3 years ago or 1 year ago, and it's used again in some other attackers. So probably, and just saying probably, that these two attacks are have the same attackers in the background. They share the same infrastructure. That might be the case, might be not, but that's something you can investigate further. If this IP is only used by these attackers or by similar attacks, and there's also other similarities, they might be linked together. Another question: does this malware includes strings that can give an indication about the attackers, or can identify if it's related to another malware? Sometimes there are some strings called the BDB strings, and I will have an example about them in the presentation. And these strings can actually tell you what's the actual name of the malware, can tell you more about the attacker and what's his motivation through this malware. So this is the questions to answer. Now, how to answer these questions? There are three main stages in your malware analysis. The basic static analysis, one which is looking at the text inside the malware, we call them strings. We look at the BE header, which is the header that in the beginning of any exe file that describes this exe file and describes all its characteristics, its own sections, and so on. And there are other data inside the exe file that we can look at and understand the malware functionality. We can also run the malware, which is the behavior analysis part. We can run the malware and see what it does, either inside a sandbox or through monitoring with API monitoring or process monitor, or through manual monitoring, or through network analysis. That's for all the instrumentation with the malware without actually looking at the code. We can actually look inside the code, which is the third phase, the code analysis, and understand the assembly code or the script code inside this malware. And code analysis basically has also dynamic and static. So we can analyze the code by just reading it, or we can also run it and see what it does in the memory, what changes happen to the code in the memory if it decrypts itself or something like that, and as well what's the changes happening in the memory through the time, so we can understand what it's actually doing. So basic static analysis, looking at text or headers, behavior analysis by running the malware and monitoring its behavior, and code analysis by looking at it, by reading its code, or monitoring its changing of the memory, monitoring its memory modification, and reading the code through the dynamic analysis. So we got a sample. What we should do exactly? First step is we will unpack the malware, and we'll also understand what's the style of malware. Is it a PHP file? Is it a .NET malware? Is it a normal exe file? Is it Mac? Is it Linux, Windows? Understand that, and as well if it's backed and there's a way to automatically unpack it, we unpack the malware. Once we unpack this malware, we go into the basic static analysis, looking at the strings to understand more about the malware, read the header, the import and export table, we'll talk about them soon, and check if there's any additional files added to our resources. Resources is a place where they have the icons and different things, and they might also have additional files or additional compressed files inside that resources that we can extract and understand as well. We can go into the behavior analysis, which is basically analyzing the network communication using Wireshark or Network Monitor, and monitor the internet activities as we saw in the previous module. With all the files have been created, modified, registry entries has changed, mutexes, and all of this information. There are tools that can monitor what's the changes the malware is doing to the system, and we need to understand exactly what it's doing. Also, we can look at the exact functions, exact Windows commands the malware is using. This Windows commands is called APIs. And these Windows commands can basically tell us a lot about what this malware is doing, just by seeing the type of commands that are being used. We can even get a memory dump or do the live forensics as we did in the previous training and understand the malware while it is running. So that's the behavior analysis part. In the code analysis part, which is the last phase, we can go into manually unpack the malware if it was still backed, and we can, through the code analysis, we can search through any interesting routines, like how it communicates to the attacker, the communication routines, or the the communication functions and how exactly it encrypts the request or decrypts the request from the attacker or encrypts the responses that being sent to the attacker back. We can monitor that and seeing the memory changes along the time while the assembly code is running and stop in specific points to be able to understand exactly what's the data that will be encrypted, the response that will be sent to the attacker. Before it's being encrypted, we can see it in the memory in plain text. We can see exactly what the attacker has, what the malware has collected. We can also see the attacker requests after they has been decrypted in the memory before they have been executed by the malware. So we can see exactly what's happening under the hood, let's say. And code analysis is mostly the last step because this is the most time-consuming and complex step. So this in this step that mostly you dive into the code, and it is the longest thing, so we leave it always at the end. The idea here is that with the static code analysis, basic static analysis and behavior analysis, that helps you in these two steps to decrease the time that you consume in the code analysis. You didn't need to fully analyze every single piece of code in the malware. You need to use your information from the basic static analysis and behavior analysis to understand the malware functionality, and just to have some things to confirm, some functionality you need to understand more, and code analysis can help you to either confirm some behavior that you saw, confirm the use of them, or to just analyze the missing pieces in the malware through code analysis. So it should not be code analysis is your only step when analyzing a malware. If you want to not spend 2-3 weeks analyzing one sample. So that's the process. What tools we'll be using? So we'll be using BStudio. We'll be using it today. We'll be using as well system internal tools, which is like Process Monitor, Process Explorer, Autoruns, and others. And this tool helps us to see what the malware is doing while it's running on the system. Autoruns, as you might know, it gives you all the persistent methods the attacker is using, and so on. We'll be using FickNet to monitor the internet communication of the malware, even if the domain is down, the website, the attacker domain is down, or you don't want to actually make your virtual machine connect directly to the internet. You can use FickNet to simulate an internet simulator responses from the domain, make the malware see that the domains are always active, and see the malware request to the attacker website. We'll be using as well CyberChef. CyberChef is basically an open source web app that helps you to do some string searching, some string manipulation, file manipulation. It's really useful in decoding some encoded strings, decrypt some stuff, extracting some data. It's really very helpful. Also, it can be able to disassemble some code. So it's very helpful in so many things. And we'll be using it in our basic static analysis today. So it's one of the important tools. And one of the most important tools for code analysis is IDA-Pro. And this helps to disassemble a malware, to see it in the assembly code. I know you might see assembly code as a very frightening thing, but we will look at it today and you will see that we don't need to understand all the code. We don't need to understand all the instructions. We just need to find clues on what this malware might be doing. And that's what we will do today. So the last tool I will talk about is Only Debugger. And Only Debugger is a tool for dynamic analysis. Only Debugger is an old tool. Now there's x86 and x64 debugger. And it has exactly the same interface. And it's a very simple tool to read the assembly code and as well run that code in the memory and see the memory changes along the time. So you can stop the malware at any point in any line of code and see what's the changes happening in the memory. And that helps a lot. Even if you don't understand so much the assembly code, you can see the memory changes, and with that you can understand what might be the malware is doing. Another tool as well, forgot to mention the resource hacker, which helps to extract resources. Let's say, as we said, these resources include the icons and some information, but as well it might include another exe file, another zip file, for example, a compressed file, some binary data is being used somehow to be injected, and so on. Some malwares, they use the resources to include additional malware that drop on a system and execute them or inject them inside other processes. And it's important to check the resources of every file to see if it has any additional suspicious files. So let's get started with the basic static analysis.